Welcome to Real GMAT Problems, episode 33. Doing real GMAT problems is one of the surest ways to make test day go well, so let's talk through a few examples. The problems that we're going to go through today are from the 11th edition of the official guide for GMAT review, and you can web search them if you'd like to follow along visually. Just so you know, the 11th edition of the official guide is out of print, and that's partly why I'm going through questions from that book, because that way, if you purchase this year's official guide, which is generally a great resource to have, there shouldn't be any overlap between the questions we're going to work through here. The official guide contains retired problems that have appeared on past GMAT exams, so these are going to be very, very similar to what you're going to see on your official GMAT. I'll give you a chance to work through the solution on your own if you'd like, and then I'll discuss my thoughts on what to take away from each problem. I recommend pausing after I read through each one and trying to solve it on your own, or at the very least, visualize how you would solve it. You might not be able to execute all the steps in your head if you are on the go or at the gym, but just do your best. It's a great mental workout. If you are in a situation where you can physically write down what you would on test day, that's ideal. We've been doing a lot of long and complicated questions, and today I thought it might be a good idea to keep things a bit shorter and focus on algebra and arithmetic type questions a little bit more, rather than a lot of the word problems that we've discussed extensively at this point in the series. Now, there's a lot of reasons we've been digging deep into the word problems. They're really easy to miss them, even if the math isn't particularly complicated or advanced, and they're really, really common on the exam. But these types of questions we're going to go through today are also super valuable. You'll definitely see stuff like this on test day. And whether you find these easier or harder than the other types of questions we've been going through probably depends a lot on your existing skill set. Some people are just more naturally inclined to do the computation type stuff that we're going to work on today. Other people are more inclined for the story type stuff. Some people are in between, but I think it's going to be very worth exploring a few shorter problems together today, no matter what situation you're in. And we'll have plenty more long ones to come as time goes on. Let's start with a warm-up problem that's a little bit lower on the difficulty scale, and then we'll bump up to some questions that seem a little bit more challenging for folks. This is problem number 148. The problem says, what is the least integer that is a sum of three different primes, each greater than 20? I'll read that again. What is the least integer that is a sum of three different primes, each greater than 20? Option A is 69. Option B is 73. Option C is 75. Option D is 79. And option E is 83. As always, I recommend pausing and working on the problem on your own. I'm just going to jump into the solution so we don't have a bunch of dead air here. Great warm-up problem for a bunch of different reasons. It's good to test your basic definitions. We've got primes, we've got sums, that kind of stuff that if you're just starting out, might have been a while since you thought about. It's a great way to test your approach to reading and taking note of the constraints of a problem well. And it's not too long or complicated. So it's a really good way to get things moving before we dive into some slightly more complex situations. On the surface, I think this one looks pretty tame, but we do have a solid number of us missing it. About 14% of us end up going for some variation of the wrong answers. 6% of us are going for one particular incorrect answer, so we'll talk a little bit about why that might be happening and how you can fix it. So by the numbers, it's not necessarily the toughest question we've looked at together. Like some of the tougher ones tend to be like 30, 40, 50% of us missing it, sometimes more. But clearly it's one where at least some of us can use some help. So figured it was worth discussing. Let's start with the correct solution, and then we'll talk through some of the pitfalls. First things first, if you are aiming for a top score, let's say above the 90th percentile on your overall three-digit score, like a 655 or higher, so like you want a 685 or a 705 or something like that, I definitely recommend memorizing all your primes up to 100. I think past 100, it's very unlikely you're going to see that in any meaningful way on the exam. And usually if you're dealing with prime numbers past 100, there's some kind of like trick or pattern you can spot in the question. You don't have to do any direct computation there. At least I've never seen a GMAT problem do that. Certainly possible, but it's just the problems are hard enough as they are without people going to primes above 1,000 or something. It can take a little bit of time to memorize your primes up to 100, but I personally have found it to pay off quite well. And this problem is going to be a good example of how that pays. Having memorized them can just give you a little bit more confidence, a little bit more conviction, a little bit more speed under pressure. And I think all of those are really, really helpful, especially if you're going for the top tier of the exam. If you're not looking for that high of a score, it's probably overkill. So I wouldn't necessarily recommend it if you just want a 605 or a 555 or a 505 or something like that. Clear the bar for the programs that you're looking at. Yeah, probably no need to memorize the primes up to 100 there. You can figure them out one at a time. I'll talk you through what that might look like in a second. This problem, coincidentally, is also a good example of how it's not too tough to kind of like derive the primes that you need in order to get these types of questions correct. So let's talk through how to figure that out, assuming that you haven't memorized them already. Starting with 20, there are two reasons that's not going to be one of the numbers. First, 20 is not prime. The definition of a prime number on the GMAT is a number with exactly two distinct factors. Okay, exactly two distinct factors. Note that one is not prime based on that definition. One has only one factor. We need two distinct factors. So by that definition, two is the smallest and the only even prime number. Okay, so definition of prime number on a GMAT is a number with exactly two distinct factors, no more, no fewer than two. And typically those factors are one in itself. There's a lot more on that in the basic definitions episode of the Math Basics series, which we'll link for you in the description of this content. So by all means, please check that out if you're just getting started and you're like, whoa, prime numbers, it's been a minute. That's totally fine. It had been a long time since I thought about prime numbers when I started studying for the GMAT as well. And you'll get back on the horse with all that stuff in due course, and it's more than worth it. Again, by the GMAT's definition, one is not prime, two is the smallest, and importantly, the only even prime number. All other even numbers are going to have more than two distinct factors. So again, it's just worth mentioning that with this particular problem, if the number's even, it's not going to be prime unless it's two. So there's one reason we're not going to include 20. It's even, it's above 2, ergo, not prime on the GMAT. The other reason is that the problem says greater than 20. So that means we are not including 20 by definition. If we were supposed to consider 20, the problem is going to say something like greater than or equal to 20. And GMAT problems are good in the sense that they're always really, really clear about where those boundaries are. I guess I can't say always. We've talked about a couple things in past episodes of this series where like it could be open to interpretation and you might have to memorize certain things, certain words that they use in ways that we're not used to. But by and large, they have a strong intent to be clear about those things. And so if this problem does not say greater than or equal to 20 and it just says greater than 20 or between 20 and 25 or something, then that means it's not including those endpoints, okay? So let's start by looking at 21. That's not even, but it does have more than two factors since it's divisible by both 3 and 7. So that can't be prime. 22 is even, so we'll skip over that. And by the way, if this question was easy for you, I'm going to go through this explanation somewhat quickly, and then we'll get into the harder stuff in a moment. So 22 is even, that can't be prime, which brings us to 23. And you can try to divide that by a bunch of numbers, but you'll realize fairly quickly that you can't, and that's because 23 is prime. So that's the first of our 3 primes that we're going to want to sum up to figure out what is the least integer that we can get. Let's keep going. 24 is even. 25 is 5 times 5, so that has more than 2 distinct factors. 26 is even, and 27 is 3 times 9. So quick side note, this is a great reason of why, a great instance of why you've heard me recommend so much that memorizing your times tables is a good idea. It's just one example of that. There's many, many examples of why times tables are good to memorize for the GMAT. You don't have a calculator on the quant section if you're just starting out. It's really important. And I recommend personally memorizing your times tables up to 20 times 20. A lot of people, when they were young, stopped at 10 times 10 or 12 times 12. But on the GMAT, it's really helpful to know what 13 times 17 is off the top of your head. Again, it can take a little bit of patience, a little bit of work, but if you consider what the upside is here for you, I think you'll find that the investment cost is more than worth the benefit. Okay, so we got 23, can't do 24, 25, 26, or 27. We get to 28, that's even, but 29 is prime. So now we've got 2 of our 3 desired numbers. 30 is even, but then we fairly quickly get to 31, which is also prime. So there are some shortcuts you can memorize for how to tell if numbers are divisible by 2, 3, 4, 5, 6. Definitely feel free to search those if you want them, or if you're working with a paid provider who recommends that you memorize those tactics to know when things are divisible by 4, by 5, etc. I endorse that. I think it's a good idea. But memorizing times tables is often enough. So I wouldn't say it's crucial, but it is helpful. It's more of a personal choice, I guess, if you feel strongly about having the most complete approach to the exam possible. If you're like a completionist, then definitely get some tricks up your sleeve, at least for the single digit numbers. Like know the tricks for how do I know if a number is divisible by 2, 3, 4, 5, 6, 8, 9. Those are the big ones. Now, in this problem, we've already got the three smallest primes greater than 20, 23, 29, 21. That's good news. That's going to help us make the smallest sum possible, which is what the problem's asking for. So let's go ahead and just add those. And check out our Math Basics episode on long addition linked below if you need a little bit of help with adding numbers manually. If you add those up correctly, you should get 83, which is the right answer. And that corresponds with our correct answer choice of option E, as in echo. Ideally, this one goes fairly smoothly for you if you've been studying for a while. Again, I mentioned if you're just starting out, it's probably a few sticking points there, but hopefully it gives you an idea of where and how you can resolve those. Maybe it's obvious, but hopefully this problem also illustrates that if you've got your primes up to 100 memorized, then the problem's going to go way, way faster than even the way I was talking through it, which isn't terrible, but it's nice to be able to be like, oh, cool, 23, 29, 31, bam. That's helpful. So you're going to pay the price to memorize it in advance, like any investment. But like most good investments, it pays off later on test day if you see something like that. So where might people be going wrong in a situation like this? Mentioned this earlier, about 14% of us are missing it. Healthy number of us are going for A, which is 69. And I thought about it a lot. I think that's probably happening because folks are missing the word different in the question. So recall that in the question text, it says the sum of three different primes. So I think what people are doing if they miss that is they do correctly figure out that 23 is the first prime after 20, and then they're just adding 23 to itself several times. And if you do 23 times 3, you'll get 69. And you see that in the answers, and it's like pretty tough to not pick it at that point. It's definitely an understandable miss. We've talked already in past episodes about a few techniques you can use to keep that kind of thing from happening, like just straight up missing a word in the problem and getting the question wrong as a result, even though you do correct math. But if you just implement a quick double check read, like reread the question before you commit to your final answer, I found that to be a really useful, really simple habit. Doesn't soak up too much additional time on each question. It feels like it's taking you a lot longer than it actually is if you look at the clock time. So highly recommend you use a stopwatch and check like how much time am I really adding to every question by rereading it and double checking. And of course, if you're never missing questions that you know how to do for those kinds of reasons, like literally 0% of the time, then don't add any additional double checks. But that's just super uncommon. Like I don't know that I've ever talked with anyone who's ever taken the GMAT or worked with anyone directly who didn't miss some questions that they knew how to do some of the time, especially in the quant section. It's a huge deal. So that double check, again, it's an investment. Yes, it has a cost, but I think you'll find that the return is more than worth it. Interestingly, about 6% of us are going for option B, which is 73. That one I found a little bit more puzzling. So if you went for 73 on this one, definitely reach out and let us know what might have happened for you there. You can always get in touch with us at the GMAT Strategy on current social channels, or you can email us, contact@thegmatstrategy.com. And I thought about 73 a little bit. I'm not totally sure about this. But my two thoughts were people are doing 21 plus 23 plus 29, so just like incorrectly identifying 21 as a prime number. That's a possibility. That would yield 73. Another thing that occurred to me is that folks are probably doing 19 plus 23 plus 31. So like missing the greater than 20 piece, doing 19, which is prime. 21 is not prime, but 19 is 23, and then missing 29 somehow and going for 31. That one I found like a little bit of a reach. Not 100% sure about that. Seems maybe not like the most likely thing, but the more I thought about it, the more I thought like it could be reasonable. I could definitely see folks doing that. So yeah, even though I'm not 100% sure why B is so popular, given that 6% of us are choosing it, it's definitely worth reiterating that double check habit would help with the whole greater than 20 thing also. Like if you went for 19 plus 23 plus 31, Double checking the question wording would help you avoid that and be like, oh, yeah, 19 can't use that. Has to be bigger than 20. Could see folks missing that again. If people are doing 21 plus 23 plus 29, though, that indicates more of a content issue, not necessarily like a process issue. And that's where memorizing the primes and memorizing your times tables, like I talked about a couple times, can be really, really helpful. So I think a lot of this problem is probably going to come back to that for the vast majority of us. So if you feel like you could know your times tables better, or you could know your primes under 100 a little better, both of those are really good takeaways from a question like this. But if there's something else for you to remember, like something more process oriented, I'd recommend just pausing the episode here and taking a moment and just asking yourself if there's any notes to self that you'd want to remember for future questions, something you can take away from this problem based on our discussion here, whether that be a change in your study routine or your approach to actual questions. It's a great idea to text or email those to yourself if you're on the go. If you're in a more stationary position and you've got a way of tracking what you're learning from each question, then now's a great time to add to that. If you're not tracking what you're learning from each question, that's a big missed opportunity in my opinion and my super extremely extensive experience at this point. So highly recommend that you just have a simple note on your phone or spreadsheet, or could be lower tech like just pencil and paper, and just make sure that you're keeping track of the most important things that you're learning along the way as you go. Otherwise, they tend to fade into the background because all of us are just processing so much information on a daily basis. Yeah. Anyway, hopefully that point is like super obvious. But if it's not, it's worth making. So I'll let you pause and make that. Whenever you're ready, let's try out another example, and one that I think is maybe a couple more layers, maybe a little bit more complex. This is problem number 144. The problem says if, in parentheses, 4 minus x divided by, in parentheses, 2 plus x. Okay, so we've got 4 minus x on top of a fraction. Underneath the fraction bar, we've got 2 plus x. If that expression, 4 minus x over 2 plus x, equals x, what is the value of x squared plus 3x minus 4? Okay, so again, getting away from the word problems, going more toward the computational algebra arithmetic stuff, I'll read this problem again. If 4 minus x divided by 2 plus x, if that fraction is equal to x, what is the value of x squared plus 3 times x minus 4? Option A is -4. Option B is -1. Option C is 0. And option D is 1. Option E is 2. Again, I'm just going to jump right into the solution, so please pause, take your time, get as far as you can solving this or imagining how you would solve it and visualize what you're writing down. Obviously, we're moving beyond basic arithmetic and definitions here, unlike the previous problem, but if you're comfortable with your algebra skills, this one probably does go your way. Having said that, if you are earlier on in the process, or maybe it's just been a long time since you've thought about algebra, we do have a Math Basics episode linked below for you to help. In fact, we've got two. You'll probably want to listen to the equations episode, which is linked below, and the quadratic equations episode, which is linked below. Both those skill sets come up in this particular problem. Decent number of us are getting this one right, 83%. So just a little bit, quote unquote, harder by the numbers than the previous problem. Not tremendously harder, but a little bit. But still, 17% of us are not able to make it to the finish line correctly here. And those wrong answers are heavily concentrated on option D as in delta. 9% of us are going for that one. And option A as in alpha, 5% of us are going for that one. So totally fine if you ended up choosing one of those answers. Mistakes are part of the learning process. As long as you're learning from your mistakes, they're valuable. So let's try to learn from both of those potential pitfalls a little bit. What's interesting about those wrong answers in particular is you're actually expressing a fair bit of depth of knowledge, because when I thought about why so many of us are going for those particularly, I realized it's probably because we're factoring the given equation and solving for x. which means like you did a lot of correct math and you had like a pretty insightful approach to the problem. It's just that the problem is not asking you to solve for x. So let's get a little bit more specific about that. How that might look, there's a couple different ways this could happen. You might look at the given equation, 4 minus x over 2 plus x equals x, and you might have performed some algebra on it to turn it into x squared plus 3x minus 4. And then you might have set that equal to 0 and factored it. That's, again, like a really positive instinct. There's many situations on the exam where you're going to see a quadratic equation, just means like you've got a squared term in there. You've got a quadratic equation, you set it equal to 0, factor it. That's very, very useful. You'll definitely want to know how to do that. If you've been studying for a while, it might have been familiar enough that you're like, oh, cool, another one of these. I'm just going to like go through my process and go ahead and find the solutions for x. And if you do factor it correctly, I'm not going to go through the actual factoring here. That's all detailed in the math basics episode I just mentioned. But if you do factor it, you would get x plus 4 times x minus 1 equals 0. You might notice there's two values of x that make that equation true. -4 is one of them, and +1 is the other. Those are called the roots or the solutions of the quadratic equation. And option A is -4. Option D is +1. So if we're thinking about why are so many people going for A and D, it's probably because they're just like missing exactly what the question's asking them to do. Looking at a familiar pattern, factoring down the quadratic, solving the quadratic correctly, I might add, and then picking one of those incorrect answers. So I don't know for sure. I haven't watched someone solve this problem in quite some time, but that's my guess. That's my guess as to what's happening here. It seems very reasonable. And it's kind of like a muscle memory taking over where you like see the quadratic, you think, oh, cool, I know how to solve this, and then you just go for that. Now it's hard to blame folks for that. Many times, if we're struggling with the quant section, we're just super excited to see something we actually know how to do. So that's really understandable, but obviously we don't want to be doing a bunch of correct math and getting the wrong answer to the question. So let's talk about how to prevent that kind of thing. First is you want to think a little bit deeper about exactly what this question is asking you. The literal words say, what is the value of x squared plus 3x minus 4? It does not say what are the solutions to x squared plus 3x minus 4. It also does not say what are the roots of x squared plus 3x minus 4. So if you went down that wrong path, you might want a flashcard or at least some kind of note to self about the difference between what is the value of blank versus what are the solutions to blank. That's a very subtle but very, very important difference. It's easy to miss. And probably a lot of us just look at the question and just think like, oh yeah, roots, that makes sense. I've done this a bunch. Now, what's interesting about that is if you correctly interpret the phrase, what is the value of x squared plus 3x minus 4, and you did the solution path I was talking about of reordering and using algebra on the given equation, which was 4 minus x over 2 plus x equals x. If you did that math correctly, you would have gotten x squared plus 3x minus 4 equals 0, and you would have been done with the problem already. Because when a question asks you what's the value of x squared plus 3x minus 4, it's just asking you what does that equal? What's on the other side of the equal sign if you have an equation with that on the left? What's on the right? And you already knew that. It's 0. And that is the correct answer to the question, which happens to be C, as in Charlie, okay? So it's kind of an interesting problem where clearly, over 80% of us are getting down to C, or at least guessing correctly and figuring out what the right answer is. So it's not like the hardest thing ever. But I mean, if you imagine 100 future MBAs in a room and 17 of them are going down that path of just factoring, then it's a little concerning, I think. It's like, okay, as a group, maybe we should do something about that. Maybe we should try to help each other out and see if we can elevate business leadership overall, so to speak. Also, ignoring the fact that we're, elevating the economy, elevating the businesses we work in, being better managers, better leaders. People tend to behave at home the way that they're taught to behave at work. I know that's not true 100% of the time, but I mean, you look at the behaviors, you see it kind of averages out. That's been my experience. So leadership really matters. Business leadership really, really matters. And yeah, maybe this isn't like a silver bullet or something that we're doing here, but I mean, it helps. It helps if you improve yourself, you become better educated, and you become a better business person. Like most of you are super awesome, super hardworking, super ethical, super kind, thoughtful. like really, really good business people. I'm sure there's folks out there who are doing stuff a lot of us wouldn't approve of, but what's the antidote to that? Well, there's a few I can think of, but one of them is just make more better people. So just want to say I'm really glad you're here. I'm grateful to have the opportunity to contribute to your success. I want to help out as much as I can. And if a lot of us are missing this question and all we got to do is make a podcast episode to avoid that, that seems like, a pretty good bet. So if you disagree with me or you think I'm wrong about that, I'm definitely open to your feedback as always. And if I'm wrong, I want to be corrected. But so far, based on what I've seen with my clients over the years, really scaling their success, becoming beacons, becoming role models, becoming decision makers, great investors, having more of what they want. It's cool. It definitely feels really good to do that, and it's been a pretty good hit rate so far. So hopefully that's going to be you too. I have a good feeling about it. So it's a bit of a tricky question here in the sense that you could know all the math, do a bunch of correct math, and still go down the wrong path to the wrong answer. So it's also interesting if you're doing a great job reading, taking notes, and maybe even double checking the questions, then you're just way, way, way less likely to make mistakes like that. So it's a good follow up to the previous question. Again, some of us might need work on our algebra skills here. That's totally fine. I needed work on my algebra skills when I started studying for the GMAT. We pretty much all needed that at the start, and it's a fairly straightforward thing to learn. There's a lot of relearn, I should say. There's a lot of great resources out there on the internet. We've put together our Math Basics series, done our best to make that awesome for you. So hopefully that part is not going to be too tough, but it might be tough. You might have had bad algebra instruction as a kid, and it might be a challenge to upskill. But again, just think about the payoff. Like it's an investment. Of course, there's going to be a cost. And if the return's there, then we don't want to be irrational and not make the investment just because the cost is high. That's how I like to think about it. So can take practice, but that's usually all it takes to get the algebra stuff to click. If you are solid with your algebra skills and you still missed this question though, or you notice yourself missing a lot of questions like it, then you'll want to invest time in working on your process. It's less about the content piece and more about like your steps, meaning the actual steps you take to read, understand, solve, validate your solutions. That's less about your math skills, perhaps obviously, more about your habits, more about your test taking skills. And you can see that's super, super important on an exam with no partial credit. If I do all the right math in a school test and then I do the, one digit off on the answer, I might get 9 out of 10. But on the GMAT, that's a 0. So I got to really have all my ducks in a row, got to dot all my I's, cross all my T's. If you're familiar with those expressions, basically your game has to be tight. You don't want to be taking the GMAT fast and loose unless you're seeing the results you want to see already. If that's you, that's awesome. Great. Obviously, don't change if you're seeing the right results. Never going to argue with your results. But if you're frustrated, if you're not seeing results, don't be sweeping this kind of stuff under the rug, everybody. That is a huge, huge problem that is going to fester and come back to really haunt you. You want to really look yourself in the mirror when you're making mistakes like that, missing problems that you know how to do. And you want to have that heart to heart with yourself and say, hey, this has got to stop. What's it going to take? Okay, don't be afraid to be hard on yourself. Don't be afraid to be the right amount of hard on yourself. Obviously, you don't want to be so hard on yourself that you're like breaking down your confidence and making yourself feel terrible and, like hurting your odds of success. But also, you don't want to be so easy on yourself that you're not improving. That's a waste of time. You're just sitting there doing GMAT problems. I can think of a lot of better things you could be doing with your time. You want to be studying with a purpose. I mean, unless you want to do what we do, I mean, definitely reach out and let us know if you want to be doing GMAT problems for till the end of time, till you drop. Then we've got a spot for you at TGS. But that's not most people, and it's certainly not most of you. You're here to get on to the next thing and get to the good stuff, so to speak. And that's why we're here trying our best to help you do that as quickly as possible. And that's super understandable. So again, recommend pausing here, making any notes to self that you think are going to be valuable. And then we'll take a look at one more question that's short, but by the numbers, a bit more challenging than these first two. Okay, this is problem 143. Short problem. it says 3.003 divided by 2.002 equals. Okay, so the whole question is just one fraction. 3.003 over 2.002. And you're going to be asked to pick the answer that has the equivalent value. Option A is 1.05. Option B is 1.50015. Option C is 1.501. Option D is 1.5015. And option E is 1.5. Again, feel free to pause. Please pause. Take your time working on this one. See if you can get it. I'm just going to jump right in. Bit more challenging than the first two problems by the numbers. 27% of us are missing this one. So quite a bit more than the previous one. Only 73% of us getting it right. Now, I think that is like because it's potentially a computation heavy problem. Certain types of people are going to find this one super easy, like it's just going to click for them and it's going to be obvious what the right answer is. And then other types of us, we're going to find it really, really tough. And then there's going to be everybody in between. But I think we're probably falling into one of those two extremes on a question like this. Either way, I think there's a few valuable lessons here. So let's just dive in. First, long division, definitely a great option here. If you're not sure how to do long division with decimals, we've got a math basics episode specifically on that topic linked below, specifically on decimal long division. Most people haven't practiced that very much in the last 10 years if you're studying for the GMAT. I don't think I had ever done long division with decimals before studying for the GMAT, so no worries if you're starting from scratch with that. It's totally normal. I'm not going to go through all the decimal division process on this specific problem because it's pretty labor intensive and I've gone quite in depth in that math basics episode. But suffice to say that if you perform the operations properly here, you are going to get the right answer. So that's why it's nice. It's a sure bet. If you don't make any mistakes with your decimal long division, like you basically can't lose on this problem, which is really nice. It's not necessarily pretty, might not be the fastest approach. I'll have an alternative for you in a second. But I did want to just harp on it because it's super practical, definitely gets the job done. And unless you're one of those people who gets questions like this right 100% of the time with no effort and no long division, I highly recommend at least being familiar with the process of doing decimal long division, if not taking some time to get polished and fast and confident with it. It definitely pays off. So, my guess as to why so many of us are going for answers like B, 10% of us choose B, and D, 9% of us choose D, is probably because people are starting to do the long division and then just getting a little lost or sidetracked or like making a mistake in one of the steps. And that can happen if you haven't practiced enough. Again, super understandable, but also the reason for my prior recommendation to at least be familiar with it, understand the steps, and know that you can execute them without mistakes, even if it's a little bit on the slow side. That would be enough to get a question like this right in a reasonable amount of time. So that's my guess. As far as the pitfalls go, like first pitfall would just be like doing long division, but then like not having practiced it enough and making a mistake. Easy to see that happening. There's also a decent number of people picking those answers probably just visually though. So I'll just remind you, B is 1.50015 and D is 1.5015. So if you just look at the fraction and do like the first 3 over 2 and then the 0.003 over 0.002, like visually it kind of looks like maybe that's going to end up being the right answer. I am speculating there, but like it seems reasonable. Um, but that shows definitely a misunderstanding about how decimal division works. So if you were tempted by that thought process again, please just practice a little bit with decimal long division and you should be good to go. Okay, now that I've made my case for the value of long division, let's consider an alternative. Another way to look at the question is factoring. And if you're not sure what I mean by factoring, it just means rewriting the numbers using multiplication. For example, one way of factoring the number 10 is to write it as 2 times 5. So I'm writing it as multiplying two of its factors, or two numbers that divide it evenly. That's what a factor is, divides another number evenly. Similarly, you could rewrite 20 as 1 times 20, or 2 times 10, or 4 times 5, etc. 1 and 20, 2 and 10, 4 and 5, those are all factors of 20. That might seem somewhat irrelevant here, but it's actually a pretty good solution if you can recognize it. More on that in a moment. In fact, let's just dive right into that. So let's say you could look at 3.003 and realize that that's the same as 3 times 1.001. Let's just say hypothetically that you could recognize that. Again, I'll circle back on like how to recognize that, but let's just say that you could. And we rewrite 3.003 as a multiplication, 3 times 1.001. Let's say you could also look at 2.002 on the bottom and recognize that that's 2 times 1.001. If you could recognize that, and I know that's going to be easy for some people and a stretch for others, then you would be able to cancel out 1.001 from the top and the bottom of the fraction, which would leave you with just 3 over 2. And that would lead you to the correct answer of option E, which is 1.5. Okay, so more on this in a second, but real quick, just check out our Math Basics episode on fractions linked below as well if you're not sure what I mean by canceling. Okay, it might have been a while since you had to cancel some terms from the numerator and denominator of a fraction. That's fine. Now, let's talk about that approach a bit more. It's definitely faster than long division, for sure, but it's not necessarily obvious. So let's talk about how to recognize that and get better at recognizing those kinds of opportunities on future problems. This might be obvious, but one way is to solve real GMAT problems during your practice sessions. Hence our time invested here. But another good tip for that is to look out for numbers in problems or terms in problems that look quite similar to each other. Here and in future quant questions, you'll want to notice, okay, 3.003, 2.002, they look quite similar. They got similar numbers of non-zero terms. They've got similar numbers of zero terms. They've got similar numbers of decimal places. So that's a discernible pattern of repetition. That doesn't always mean that you're going to be able to use factoring to your advantage, but it's a common enough pattern that it's highly likely factoring can help. And so it's worth at least exploring a solution that involves factoring when you see that kind of thing in the future. Just ask yourself like, could I factor this thing, rewrite this thing to make it a little bit easier on myself? That's a really useful pattern and definitely something I've seen more than just on this problem after having done this a truly countless number of real GMAT problems in my life. There are a lot of other places that factoring can be useful, but this problem is a good example of the concept of, hey, these numbers look similar. Can I factor something to make this problem easier? Like that's the most basic type of pattern that you could use factoring to good extent on. And I'm sure we'll get to some of the more complicated ones as the series goes on. But let's just keep it simple for now so that one is hopefully firmly memorizable. So those are just a couple of the things that I thought would be valuable for folks to discuss there. Hopefully you do too. Again, I'd recommend pausing here, making any desired notes to self. You might even want to file this question away to resolve it in the future to see if you can recall the alternate solution that might have been a little less obvious to you. It certainly wasn't super obvious to me the first time I did this question. I ended up doing the long division route. Worked, but maybe not as elegant as the factoring one. If you resolve questions as time goes on, like if you file questions like this away where you're like, oh, that's an interesting pattern, I might want to use that in the future. If you resolve this question a few times in the coming weeks or months, it's way more likely that you're going to recognize that kind of pattern if it shows up on your official exam. So highly recommend keeping a list of those kinds of problems and going back to them on a regular basis. I've made that recommendation in many, many, many past episodes. But if you haven't listened to those, there's one called How to Start Your GMAT Studies in 2025. Really important to do the updated one, not the one from 2019, because the GMAT went through a big change a couple years ago. And I talk about that there. And I think I also talk about that technique in the How to Build Speed episode. So I think it's called How to Get Faster at GMAT Problems. And plenty more of that, more like how to organize your study time, more strategic pieces of content that we've made that are less about individual problems like this series and more about like the high level, how to organize your studies, how to think about it, how to progress faster, basically how to get this thing done efficiently. So hope you found today's discussion valuable. If you have questions or feedback, like I said, please reach out to us anytime at the GMAT Strategy on current social channels, or just shoot us an email. We are contact@thegmatstrategy.com. We will do our best to help you out. In the meantime, if you want more tips and strategies for optimizing your performance on the exam, please head to our website, thegmatstrategy.com, which is linked in the description of this content, and check out our free video on how you can reach your dream GMAT score in half the normal time. In the meantime, this is a regular show, so please subscribe and please stay positive and stay consistent with your studies. Talk to you all soon.